so in this video we're going over the AQA GCSE additional physics topic of velocity time graphs. Before we start, it's good to go over what velocity actually means. Velocity is almost identical in its definition to speed, so speed being how far you can travel in a particular amount of time. However, velocity refers to speed in a particular direction. So it's a slightly more useful term if you're thinking about, for example, a race. So you may well be travelling at a very fast speed, but if you're travelling in the wrong direction, then you're not going to win the race. That's the way I think about velocity. So when we're thinking about velocity, there's slight differences to speed. So objects travelling with different velocities could have the same speed, so they could be travelling at the same speed, but in different directions. For example, you've got two lanes on a motorway. You could have two cars travelling at 70 miles per hour, but one may be travelling northwards and one may be travelling southwards. And so they would have different velocities, but the same speed. They may also be travelling in the same direction, but if they have different speeds, they have different velocities. So, same direction. And finally, they may have both different directions and different speeds. So, with our motorway example, this is the most likely. There'll probably be subtle differences in speed and they'll be travelling in different directions. And when looking at these graphs, it's very important to realise that there's a big difference between velocity time graphs and distance time graphs. In velocity time graphs, the y-axis is not distance. So you need to be very careful in exams because this would mess up your calculations completely. The y-axis represents velocity, but the x-axis is still time. So let's look at these graphs. As you can see, along our y-axis we have velocity, and like speed, it's also measured in meters per second, and we have time in second along the bottom. And I'm going to compare it with the graph we were looking at earlier in the previous video about distance time, because the graphs look almost identical, and I'll show you how not to get tripped up here. So to start with, when we have a steady increase in velocity, think about velocity in the sense of speed here. Well, if you're increasing speed, you're going to be accelerating or getting faster. While as here, you're just increasing how far you're travelling. So although these two parts of the graph look almost identical, with distance time graphs, the gradient represents the speed, and with velocity time graphs, the gradient represents the acceleration. So the blue part of the graph has a much faster acceleration than the red part of the graph. So if we're thinking about cars, the blue part might be reaching 0 to 60 in less time than the red part of the graph. Then when you have a flat part of the velocity time graph, this does not mean that the object which is travelling is stationary as it did in the distance time graph, because in the distance time graph, the stationary object was staying at the same distance, so 8 from the origin, but the time was carrying on. In this, its velocity is still 8, so it's still travelling at 8 meters per second in a particular direction, but it's not increasing its velocity. So it's travelling at a constant speed. So if we're thinking about a car travelling at 70 miles per hour northwards up a motorway. And finally, in velocity time graphs, when the graph gradient is decreasing, we are decelerating, which is the opposite of accelerating. Essentially, the car is slowing down and grinding to a halt at 10 seconds. So in this graph, a car has taken off, reached its maximum speed in 4 seconds, maintained a steady velocity for about 3 seconds, and then slowly decreased for 3 seconds. But here, when you're decreasing, you're returning to the start at the same speed as you were going away from the origin. I hope this video helped. In the next video, we'll be going over the calculations involved in velocity time graphs.